My name is Professor Richard Davis, and I'm at Durham University in the UK. I'm agnostic about fracking, whether it should or shouldn't go ahead. My role as a scientist is to do independent research so that people can make informed choices. Shale gas and oil are rocks that are buried 2 to 4 kilometers under the ground. And the gas and oil can be released by cracking the rock in a process known as fracking, or hydraulic fracturing. The well is drilled vertically or horizontally through the reservoir, and then fractures are formed by pumping high pressure water and some chemicals and proppant to hold the newly forming cracks open. Shale gas and oil can flow into the well and then come to the surface. The water that's been used for the fracking process flows back to the surface and is collected, and that happens over a period of a few days. Between 2 and 16 Olympic swimming pools of water are used in the fracking process, and between 10% and 50% of that fluid comes back to the surface in what is called flowback water. Now, the flowback water has taken with it some of the salt from underground in the rock layers, and also some of the natural radioactivity that's in the rock layers that we have around us, and it's concentrated that and brought it to the surface. And so the flowback water has to be cleaned or disposed of in a satisfactory way. And the technology for that is being used in Pennsylvania right now. So flowback water does need to be cleaned and disposed of, but there's nothing technologically that can't be dealt with in a satisfactory and environmentally safe way. The aquifers, which are the sensitive rock layers which contain our water supplies, are usually within the first kilometre under the surface. The shale reservoir needs to be 2, 3 or 4 kilometres under the surface. So there's a significant gap between the reservoir being fractured and the sensitive, important water supplies which are just underneath the ground. Many countries in Europe are looking at the potential of shale gas and oil, and these countries are in an exploration phase where 1 or 2 vertical wells are being drilled to see if the shale rocks are there. If they are there and gas and oil can be produced using fracturing technology, then a full-scale development may take place in a region where many wells are drilled. The technology in the United States means that 12 or 16 wells can be drilled from one well pad, the size of a decent parking lot. And eventually, production will occur, which takes 10, 20 or 30 years to complete. The fracturing part is actually a very short period of about a month during this development and exploration phase. Production would involve a small wellhead, which is 2 or 3 meters high, and actually be quite difficult to see from the roadside. One of the key issues that's been raised in the United States and in Europe is the risk of water contamination. Many people have seen pictures of taps being turned on and someone igniting gas as it comes out of the tap along with water. And these are evocative images that worry people. At Durham University, in Durham Energy Institute, we've researched this particular risk. Can fracking cause contamination of water supplies? Now, fracking is a specific process of cracking rock underground in reservoirs located 2, 3 or 4 kilometers depth, a long way beneath our feet. And what we found is that the fractures that are generated during fracturing operations travel only a couple of 100 meters. Perhaps 600 meters is the maximum measured hydraulic fracture to date. Now, if these reservoirs are at 3 or 4 kilometers depth, and the aquifers are shallow within the first few 100 meters of the surface, then the fractures simply aren't tall enough to allow the fracture to connect the reservoir to the aquifer. So our research has found that water contamination is very unlikely indeed due to hydraulic fracturing. Where gas is in aquifers, there are many causes for how that could occur. Firstly, in aquifers, organic matter breaks down naturally in anaerobic conditions, producing what is called biogenic methane. This is an entirely natural process, and some of the gas in aquifers could have come from this source. Secondly, gas migrates naturally. Gas is buoyant and it floats, and therefore gas seeps up naturally. People have found oil and gas seeps at the Earth's surface for hundreds of years. But it is true that in the United States, they've found that some wells have leaked. Not the fracking, but the well itself has provided a route for methane and other gases to come up to the surface. And that's something that's been found in Pennsylvania, for example. This is a problem that needs to be very closely looked at. When a well is drilled, any well, whether it's for shale gas or shale oil or a conventional borehole to get conventional oil and gas out of the ground, it has to be cemented and sealed up using casing. This is steel tube and cement used to separate the aquifers, these sensitive rock layers with our water supplies in them, from deeper shale gas and oil, which we don't want to contaminate those shallower aquifers. So it's routine, and has been for many decades, to cement and case a hole as the well is drilled. And when the drilling's completed, when the well is being abandoned, the well is filled with cement plugs to separate any gas or oil or other liquids deep underground from our shallow aquifers where our drinking waters may be stored. So this is a routine process that has to be done effectively. What we know is that this sometimes can cause contamination of water supplies. It's not common. Normally out of hundreds of wells, perhaps 1 or 2%, if we look at statistics from Pennsylvania, have not been sealed properly. And so in drilling wells for shale gas or shale oil extraction, it's incredibly important the wells are cemented effectively and then are monitored, not just for the next 5 or 10 years, but for the next several decades, to make sure that they are not leaking. Because leaking wells is a valid way for gas or molecules of oil to come to the surface and enter an aquifer. So there are several ways that contamination could take place. Hydraulic fracturing is actually one of the most unlikely mechanisms. In Durham Energy Institute at Durham University, we've looked at the history of man-made earthquakes going back to 1929, looking at all the published sources for events that have been caused by a number of different mechanisms. We've known about man's ability to trigger earthquakes since the 1960s. We found from 1929 through to the present day 198 examples of seismic events, earthquakes, that were published. And we found the causes were as diverse as geothermal energy, putting water into dam systems created earthquakes. Mining causes earthquakes, and ironically, conventional oil and gas depletion, taking oil and gas out of fields, causes felt earthquakes. Hydraulic fracturing, when compared to all these other causes, is actually quite a minor mechanism. Doesn't really get into the Premier League of mechanisms for generating felt earthquakes. When fracking is done, breaking the rock to create the cracks releases small amounts of energy. It's barely measurable. We can't feel it. It's the sort of thing that can be measured using the most up-to-date techniques, using sensors under the ground. So the amount of energy that's generally released due to fracking is equivalent to me jumping up and down on this very spot. But it is true that fracking has actually caused felt earthquakes. There's examples in British Columbia, there's examples in the United States, and there's examples in the UK. When fluid is pumped underground, it could enter a fault, lubricating the fault and allowing it to move. The biggest event we know of is 3.8 in magnitude in British Columbia in Canada. In the UK, in 2011, we had an event of 2.3 in magnitude. But we've only got 3 places where this has occurred from hundreds of thousands of fracturing operations. People have focused on the key issues of water contamination and earthquakes, and those are issues that need to be carefully considered. But there are other things that could be important as well. And what people will notice when fracking operations are taking place is increased road traffic. You'll see lorries on the road. It will mean the journey to work can take longer, or the journey to take your children to school. And those are the things that people will see, and in the short term will have an impact on people's lives. The longer term issues are to check that wells are properly cemented, that they don't leak for the next few years and for the next few decades, so that we're not left with a legacy that is something our children or our children's children inherit.